Recording in progress.
Workshop, that is Conceptual Mass in Revit. So, my name is Prakriti Goyal, and I'm working in Capricorn as Senior BIM Specialist Architecture. So, I'll be conducting today's webinar, right? So, first of all, in today's workshop, the agenda is like, first of all, we'll discuss about the like brief introduction about our company, archons. So, like over here, after that, we'll have Kanchan from the ethos who will be actually giving you the brief introduction about Design Advanced 2024. And then we will be delving into the more depth, like how we can actually use conceptual mass to develop different type of forms. Basically, like if we are going for the conceptual stage, how the conceptual mass is actually useful, right? So let's first, yeah, right. So first of all, like if I talk about our company, Arcans in Private Limited is the India's leading design and construction technology solution provider. We deploy data-driven solutions across different sectors worldwide to improve sustainable project designs. We are since like 1987, and like to Arcans, the way we work, actually, we all over the world, we have three departments like America, EMEA, and APAC. And we, as an unmatched global service platforms, we are like 50 plus offices around the whole world. We are located in different 18 plus countries, and we are managing like 400,000 of users license and 1,300 solution professionals. So, like again, we are helping you to unleash the ideas for better future, right? So now I will be calling out Kanchan from Ethos. So Kanchan, over to you.
Hello, good afternoon, everyone. Let me just share my screen. I hope everyone is able to see my screen.
Yes,
Okay,
Kanchan.
yeah, thank you. Good afternoon to everyone present. I'm Kanchan, and together with me, you'll take a quick dive into the theme and the brief of this edition of Design Advanced. You may already see the name on your screen, Architecture of Assembly, Industrialized Construction for High-Rise Buildings. And the theme title itself gives away a lot about this year's theme. Uh, First off, you have to design a high-rise building. Second, you have to assemble it, and what that assembling will require, we'll get into it a little bit later. And that you have to use industrialized construction as a process. So let's get into the theme. Then let's understand what your task will be, and then let's understand what are the guidelines for participation. So, like we were speaking, like talking about architecture of assembly and how it's related to industrialized construction for high-rise buildings. So, when we talk about high-rise buildings, there are certain challenges, like it takes a lot of time to get constructed. There are issues in workmanship. There are issues in the wastage of materials as it is a very large-scale building. So, how with the use of industrialized construction and prefabricated components, we can tackle these issues head on, and how all of this can result into a better, a smoother, more efficient, faster, and a more precise outcome for all of us. So you have the task to design a high-rise residential building or complex that provides safe and comfortable living spaces. Getting closer to the theme, you know that high-rise residential buildings, they have certain repeating elements like and identical layouts of the units. Like all the units are stacked one above the other. Like all their bedrooms will have the same shape and size. All the bathrooms will be a certain way. So using that repeating strategy of repeating elements at identical layouts of units like the staircases, railings, facade, balconies, toilets. Like these are the repeating elements that you can find and that you can also see in these images that have been pasted here as reference. But because of the scale of the project and certain limitations that come due to the conventional construction process, all of these projects will take a lot of time to be constructed and to be occupied. So the builder and like whoever the owner is, like they'll need a long time and they'll have to wait for a long period for the project to be actually occupied. So, how is it possible to save time, effort, expenses, and resources while designing these buildings? How can we use these standardized repeating elements to be produced in mass, to be produced later, to be assembled later? Sorry. So, that's where the industrialized construction and the use of prefabricated components comes from. So, in a prefabricated construction, only the foundation is laid using conventional methods of construction, and the superstructure components like the walls, floors, doors, and windows, etc., even an entire toilet, a balcony, or railings, all of these can be produced in a factory and they can just be assembled later together on the site. So, this is how the process goes. The standardized elements are designed according to the requirements. Then the elements are produced in mass in a factory, whichever numbers that you require. Then the prefabricated elements are transported to the site. Once they are all produced, they will be transported to the site. And at the site, they will be assembled according to the design. Now, if you think about what can be prefabricated, there's a lot of scope for prefabrication. The fire stairs that are present in high-rise buildings, the elevator shafts, then plumbing, cooling, the ventilation systems, all of these parts can be prefabricated. The facade or the other complex design systems, like sometimes a building will have a very intricate design or a jali or something. So sometimes manual labor might not be the way to go in that case. So if you prefabricate that, that will be much more accurate. Then of course the basic components like the walls, floor panels, doors, windows, toilets, kitchenettes, balconies, etc. They can all be prefabricated. So looking at the first case study, this is a building called 10 Degrees 100A George Street in London, designed by HTA Design. So, like at a glance, it looks like any other building. Like there is no difference between a prefabricated building and a usual conventional building when you look at it. So you don't need to be scared like your building won't look nice or anything. It's just as usual. And you can see how interestingly the facade has been made. Like how can these repeating elements would have been produced and how they've been assembled on site because these are all standard repeating elements. Similarly, another example is of this apartment complex in the Netherlands. And see how interesting the facade has been made using colors and different shapes, and a lot of geometry has been applied to make it look more refreshing and interesting. So the kitchens, bathrooms, stairs, and facade were prefabricated and placed in this project. It is very highly standardized and rationalized. There are only two types of homes. So you may also want to think about like what kind of units you are making in your high-rise residential building. Uh, like if you're going for a majority of 2 BHKs and some 3 BHKs, etc., etc., that will be decided later. Then we come to the task. So you design a high-rise residential building or a building complex using industrialized construction with prefabricated building components. So to do that, you have to understand IC and prefabrication of building components. And then you have to explore suitable construction materials and components. And what will set you apart is how creative you've been with the assembly and with designing of the components. So you have to demonstrate how a transition from unorganized to organized construction practices, that is going from a conventional construction process, which usually builds everything on site. You move from that to a prefabricated assembly sort of a construction process. And how is that addressing the issues of quality, the workers' protection, and the sustainable design? You maximize the use of industrialized elements. You standardize the repeating elements in your design, and you draw inspiration from the uniqueness of the site, context, history, local heritage, arts and crafts, etc. Of course, that has to come in. Here are some of the guidelines that you need to take care of. You choose an urban site in a city within the following guidelines. So your site area should be between 5 to 12 acres. Minimum FAR that you should build is 3. Green cover should be at least 15% of the site area. Follow the local bylaws. If local bylaws are not accessible or present to you, then you can use the national building. At least 50%, and we could also think about 50 to 60% actually of the design should be constructed using IC prefabricated building components, partially or entirely. And in your design sheets that you will upload at the end, like in your submission, you have to show on 1 to 2 sheets like what kind of prefabricated components you have chosen and what was your reason for choosing them, and how has that affected the process, like, or the project, like cost savings, or how has the timeline shortened, worker well-being and sustainability. These are the design considerations that you must take care of while designing your project. Integrate industrialized construction, of course, that is the basics. You have to do an in-depth research and its in its application, the application of IC, sustainability, well-being in your design. Your design should like promote well-being for all its occupants, and you must unleash your creativity. These are your important dates. The registrations will close on October 7th and the submissions will close on October 17th. Uh, if you are a student in undergraduate or postgraduate courses of architecture, planning, civil engineering, or design globally, you are eligible to participate in the competition. Maximum of 3 members per team. You can also participate in pairs or individually. You are also allowed to make teams with your students from with different academic years as well as courses or colleges. Those graduating in 2024 can also participate in the competition. Here are some frequently asked questions about the competition. Is there any registration fee for the competition and workshops? So, as you may have noticed, like while registering and attending this workshop, no registration fee was charged to you. So, these workshops and the competition itself, these are completely free. Can postgraduate students take part in the competition? Of course, absolutely. They are completely eligible and welcome to participate. Can the team members be from different colleges? Yes, of course. We just discussed this, that different colleges, teams can be made across colleges provided all of the students are eligible. In absence of local bylaws, which standards should be used? Of course, you'll use the National Building Code. Can we choose a site on our own? Yes, you can choose a site on your own, just that the site should be located in a tier 1 or tier 2 city, and the site area should be minimum 5 acres and maximum 12 acres. Can we define our area programs? Yes, you are free to define your area program, distribution of spaces as per your site requirements. Coming to the end, if you want to register for the competition, please visit www.designadvance.in, or you can simply scan this QR code and register right now. We'll see you for the next webinar. Thank you.
Okay, thank you, Kanchan, for the design advance brief. Okay, so thank you. Now let's move on with the quiz. part, that is conceptual massing in Revit. Now, why actually we need conceptual massing? So with every design stage. So the initial stage of any design stage is the conceptual stage, where you actually develop certain forms. So it's both ways, like form follows function or maybe function follows form. So you are actually developing a form, uh, right? So after that form has been created, you will be developing that. Right, you will be developing that for your future on, like for working drawings and maybe for JFC drawings for different construction models, right? Now, conceptual massing is actually very much crucial for developing the conceptual design stage. So, if I talk about for the industrial construction as well, so the conceptual mass actually plays a very important role in developing your conceptual form for the project, which is to be visualized, like how your form, how your conceptual mass will be, like how your conceptual design will look actually. So uh, to actually like what we can say, to actually make your idea like expressible, to convey your idea, right, to convey your like design, you need a form, right, conceptual form. So that is what like we actually do in the initial design stage, right? We actually develop a conceptual form, right? Now with Revit, you can actually develop those conceptual forms using massing environment. It actually helps you to achieve simple or complex geometries, like complex different forms, maybe organic shapes or maybe like simplistic like high rise buildings, right? And those can be further on developed with the providing of different building components like walls, floors, and roofs. And after that, you can generate your documentations, right? So now let's talk about different complex structures. Uh, like if I talk about what kind of conceptual forms we can develop in massing environment in Revit. So again, we can actually develop a simplistic tower, like simple high-rise towers, or maybe complex structures like your twisted towers or maybe airport roofs. So you can see over here we have different like designs for the airport roofs. But because we have a design advance like theme, right? So we will be discussing about the uh, like for precast, like for prefabricated buildings, for industrial construction buildings, right? How conceptual mass actually helps you. So we'll discuss about different templates. The Revit actually tells you, like the Revit actually has for conceptual masses, right? So that you can actually use that to develop your forms for your project, right? So right. So this is like our homepage of Revit. So first of all, we need to identify what are the templates we have for the conceptual mass. Because first of all, our main, like if you are developing a design, so the main initial stage is your conceptual design stage. So for that, how to proceed, right? So either you can go to any project, any new project, and then you can start developing the conceptual form over there. So let me open a new project. So in this case, like I'll be using a default metric template. So our main motive is to if we are going for the conceptual design stage. So at what like if you are going for the like prefabricated components, building components in, right? So those are actually similar, right? So they are actually same components which will be assembled on site, right? So how will you be proceeding, how you will be developing them on Revit? So for that, I'll just go to see, like I'll just see over here. You can see we have this massing inside tab. over here, this is what we call this as massing environment, right? You have both options like place mass and in place mass. So if you are developing a concept, if you are developing a conception model, maybe a high rise building, like let's say twisted towers. So for that, you need levels. You need levels. Like if I talk about high rise building, so how many story building you have, right? 82 story or maybe like less than that. So for that, for developing a concept, you need levels, right? So what you can do, you can, like when you start with the conceptual design, you have to start with the levels, right? Levels and grids for structural components, right? Why we are doing this? Because we are just going for the form follows function. So first, like we are developing a form, right? And after that, we'll divide that space into different functions. So you can do either ways, right? So let's provide levels for the first, like for first maybe 3 or 4 stages. So like, yeah. So let me provide that. So I'll be providing different levels. So because this is the typical high rise building, so like you can have different variations. So right now completing till this much, right? You can go to beyond that. That's not an limit. Now, now after this, what we'll do, like once you create the levels, we will be developing the conception model. So now this is actually a project template, like project file of the Revit, in which you are developing the conception model, right? So if I go to the massing insight, over here, I'll just go to in place mass. So again, in this project, we will be developing the working drawings, we will be developing the building components, like we will be developing full high-rise buildings, right? So in this project only, I'm starting with the conceptual design. So let's make this as twisted tower. So if you have a reference, like if you have already uh, created any sketch work, like any uh, conceptual form, so you can actually insert that image in your Revit, or either uh, like if you have an elevation of that like of the tower, you can actually develop that. So what I'm doing is like we will be creating this kind of structure in the as a conception model, right? So if this is the normal sketch, right? So how to proceed with that, right? So what I'll do, I'll just provide certain like or you can do one thing, you can provide different grids. This will be our central line. So I'm providing the space for the core area. Right now, what I can do, I can just now start with the form. So in conception mass, we have two type of conception models, like one is form based and one is point based for developing like organic structures. So we'll discuss about that as well. So if I go to the in place mass, so again, we are same in the project file, that is rvt.rv, like so .rvt is the file, right? In this only we will be creating the conception form, right? So let's say this will be a twisted tower. So once you go for the in place mask, so over here you can see we'll have the interface of the like different interface from the Revit, right? So this is one thing. This is one like this is how you can actually develop your form in Revit. But if I talk about different components, like those components which are same, let's say roofs, right? Or maybe like your staircases, your maybe different facades, right? So for that, what you can do, rather you going for the project in place mass, you can just go for the family. So in Revit, we like we have a family, the component, Revit component. So you will have different template for conceptual massing as well. So what I'll do, I'll just go for new. Like over here, once you go for new, so over here you will have this conceptual mass. So it will open a complete different template, a new template where you can actually develop different type of like different type of components. Maybe like if you want to develop your maybe columns, your like staircases, your whatever portions, whatever building components that assembles on site, so you can actually develop it in this template. So it is actually for building components basically. And if you're going for the project in place mask, that is for the full project. Like maybe if you are going for the high rise conceptual design for the high rise building, so directly you are actually using the project interface, and in that you are developing that full building with the like and providing it different components like walls, floors, and roofs, etc. Right? So this is the different interface you'll have for the conception mask. Right? Now, so we'll talk about that conception mask template a little bit. So over here, so let's create the form first. So this is the project file. So over here, once you go for the mask template, so you will get the draw panel over here. So let's create the form for that. So I'll be going for the twisted tower over here. So, right. So yeah, let me just change the dimensions. Yeah, right. Now we'll have the center point and let's provide that form first. Right. Now I'll go for the creating a just layout, the flow plate basically. Right. So, right. So this course should be same. So yeah. Yeah. So this first floor plate has been created. Right now, what I'll do, I'll just twist this whole floor plate in different levels. So let's see that. So I'll just copy these like this flow plate in multiple levels. I'll rotate it and maybe 20, 25 degree, right? And I'll just copy this to different level. So I'm just placing it. So like you can see over here, so we have almost reached up to the fifth floor, like, right? It's like that, right? So if I select each and every floor plate, and then when we go for the create form, you can see that this type of form has been created. So yeah, you can see if I select this and if I go to the conceptual form, you can see, right? Yeah. Or like for smooth curvature, like for smooth curvature, you can actually create in one go, or for like for providing the balcony, you can just go to floor wise like this. So first we have to select the floor plate and then go for create form. You can see that we have now like a floor plate where we have like the portion like we can actually convert it to different building elements like curtain glazing and all, right? So let's twist this floor plate as well, 25, right? So we have to pick the floor plate, right? Like this, right? And now after this, once it is completed, we can provide the building like, so this is actually fully glazed, right? So what we can do, we can actually provide over here in the massing inside, we can actually go for the like different walls. So like over here, it is actually picking the floor to floor, floor to floor walls, right? So that once you go for like the proper like if you are modifying it, like you are providing balconies and all, so for that it will be very much easy for developing it floor to floor wise, like you can see. And if you want to provide different glazing, you can provide multiple ways. And if I go for create systems, you can see a grid system will be created like this. So this is like a basic model, and after that you can develop it. This is one way, but like this actually makes your model heavier. So that is why we actually go for a different way in which we actually use the template, the family template, the separate way. So if we are talking about the complex models like these kind of like where you develop the roofs, right? So for that, if you are going for the roofs as well, so that also can be created over here. So I'll take a different example over here, right? So now what I'll do, so like this is a different type of form, that is form like point based, where each and every point has its own elevation. So in this, like an example for this is like, so if you see over here, so if I go for the tensile structures, so like each and every elevation of the tensile structure is actually different. So according to that, like you can actually develop your structures, different structures like umbrella structures, right? So for that, one method is actually called the point-based massing is actually used, right? So, right. So again, I'll be providing certain levels for tensile structure, or maybe for any other uh, like for different tensile structures basically, right? So I'll go for 10 feet over here, and then 6 feet, right? After that, I'll go for the massing. So in this case, in this also, like I'm using the in-place mass because we are developing the roof structure. But when we develop it for the industrial construction, that is the theme for the design advance. So for that, a different approach we can take. So I'll show you. Right? So I'll just use point. I'll copy this, right? Right? And I'll use the alternative ways. Yeah. So I'll use these points to elevate. I'll cut them and paste it to different level. That is, and if I go to the elevation, I'll move it to different levels. So let's say this one. So let's say maybe 8 inches. So this will be your 15 inches. And let's say this will be your 8 feet or maybe 6 feet. Yeah. And if I go to a different level, maybe west or maybe in 3D, right? I'll just connect them over here. So if you want to ask more about this, like how we have created it, so you can actually uh, like go for the connect at capricorn.com. So we actually provide different courses. Like BIM for Design is the main course, like which like in which we actually tell this everything in detail, how we have created this. Now we like again. So for tensile structures, we just need the profile, the elevations, the cross sections of the roof, right? And then what I can do, I can just provide and connect them over here. So once this is done, I can just convert it to roof. I'll go for create roof, and we can actually create the walls over here. So it's like that. So you can see, like you can actually develop these kind of structures easily. I can change the roof type. Yeah, yeah. So you can see, right? But again, this is okay, fine. But how conception mass is actually useful for India industrial constructions, like for if I talk about prefab buildings. So over here, if I take an example of this type of building, like in which you can see that a single module is created and then it is actually placed on site in different rows, but they are actually a different sizes, right? So in this, what we can do, we can change the sizes of the mass. Like we can change the sizes of the container. Like the container sizes actually changes, right, according to the design, right? So what we can do, we can actually create a customized conception mass where we can change the sizes. So for that, the family template actually helps in this case, right? So for that, what I'll do, I'll just go for the template, a family template. So this is the family template of the mass in which we are developing certain content. So a best example, like if you see over here, best example of prefab building is actually this. Like you all may know the project. So Capsule Hotel by Kisho Kurava. So right, Kurokawa. So over here, this is actually a prefab building, right? So each and every module is created and placed on site, is created in factory, and they actually provide it over here on the site with the construction, like with the like they actually manufactured to the site and placed it according by the different methods, right? So they have placed it on the site. So these like us, they actually are small certain units which are actually developed. So for that, what we can do, we can actually use the template. So this is a, like conceptual mass is actually uh, like preferred to like your it is preferred to go for the 3D model, like 3D space where you can actually see how your model will be perceived, right? So for that, this family template is actually like preferred to develop these kind of conceptual designs, because again, if you copy them multiple, if you load them multiple in your project size will also be lighter, and you can actually design various kind of designs, like various kinds of concepts using this methodology. So first of all, I'm using the family template and I'm just creating certain sizes, like certain parameters, so that we can actually generate the like we can change the sizes of the uh, modules, right? So what I'll do, I'll go for reference plane, right? And I'll place the dimensions. Be in right? And what we can do, we can provide the dimensions. So let's provide the parameters to it. This will be length, width, and we need height as well, right? Now, what we'll do, we will be first of all checking its height, everything. So is it working or not? So let's show you, it should be like the length and height and width will be different for each and every module, like maybe core, because if you have the high rise building, so the core will be again separately created on factory and then manufactured to site and then placed it, right? So the core dimension will be different as well. So that is why I'm doing this, right? So let's say, so our unit size will be, let's say, 12 meter by 3 meter and 3 meter height, right? So, so 3 meter height, 12 meter length, and 3 meter width. So will it be working? Yes, it is working, right? So yeah, now we need to create the geometry. So again, I'm using the family portion over here, like family template over here for developing this module, right? So let's say, so now what is the next step is to do, like we will be creating the form over here, right? So I'll be using reference line. I'll be creating the line work over here, right? And I'll be using this to create the structure, right? And its height should be up to this level, right? Now let's see, will is it working or not? 3 meter. Height will be 3 meter, length will be 12 meter, and let's say the size will be like the width will be, let's say, again 4 meter. So yeah, it is working pretty fine, right? Now let's save it. So this will be our prefab first unit. So I'll name this as unit 1, right? And now I'll be inserting it to the project. So in this case, also I'll open a new project. And if I talk about the, like in this project, the one which showed you. So first of all, you can see one will be your main core, and then we'll have different units stacked together, right? So if we want to develop that, so we just need only one single uh, mass template, like only one single mass. We need to load it into the project, and let's see what happens. right? So let's say first comes your core, so maybe 6.3 meter by 6.3 meter, and maybe your 4 meter for one side, 4 meter height. So yeah, so let's say yeah, I need to make this as so I can change the height and all. So 4 meter height will be your core, and 6.3 meter by 6.3 meter will be your center core. And after that, we'll have different cubicles. So 6.3 by 4 meter will be your units, right? So what I'll do, I'll just place again. I'll go for create similar. And this time I'll change this to the length should be your maybe 8 meters, or maybe more than that, like 12 meters. And then what I'll do, I'll stack them over here, right? And what I'll do, I'll just mirror this. So for time being, if you see over here in 3D, it will convert it like this, right? Now, this is just mass, right? This is just simple mass where we have provided the spaces, right? And then after this, what I can do, I can just copy the whole thing, and just I'll change it to different level. And in level 2, I can just rotate it. So I'll just select them. I'll copy, rotate them. Yeah. So otherwise, what you can do, yeah, so it's like that, right? Now, this is like whole module, right? You are stacking the units. So your core is also getting like your core portion is also uh, separately like created in on the like in factory and manufactured on site, like, and placed on the site, right? After this, like once this is done, what you can do after this is done, we can go for the massing inside, and we can provide the different floors like flooring. So what I'll do, I'll just create mass floors over here to develop the flooring and all. So just observe like what I'm doing over here. So I have to check the building elements, like what will be the material of the roof, right? What will be the material of the walls. So this is a whole module. right? So now once the sizes actually change, right? So if I say like maybe 125, yeah. If the size changes, if the size of this module, if the size of the mass changes, let's say, so this is the unit. If the if the height of the mass changes, if the length of the mass changes, so let's say if the length of the mass is 7 meters and the width is, let's say, 12 meters, right? So your mass changes, but not your walls, roofs, and floors. So what you can do, you can select each and everything and just select each and every single thing where you have created with using uh, by face, and then you have this option update to face. So according to that, your whole construction, your whole building elements will be will be modified according to the mass. So like for prefabrication, this actually helps you to develop like these kind of concepts, like these kind of concepts you can easily develop by this kind of method, right? So this is how we actually develop the conception mass for prefabricated buildings for industrialized constructions. Now if you have any questions, we can discuss right now. You can just type in the questions in the Q&A chat box if you have any questions. Yes, so like regarding courses, you can go for the connect@capricorn.com. If you want to if you want to provide the if you want to join our course, BIM for Design course, in that we actually tell you the detail how we can actually go for the BIM implementation in a project, the from conceptual design stage and design development Capricorn. So yeah, right. So any other questions you want to ask, you can just provide them in the Q&A chat box. Yeah, I think this is the end so for this webinar. So thank you all for joining this webinar. Okay, so bye everyone. Thank you. Any more questions, you can just go down and just email it to connect@capricorn.com and then we'll answer it to it, right? So fine. Thank you everyone for joining the session. Bye everyone. Thank you.